There we go. Hello and welcome back to Calculus 2 after some time off, right? And we are going to continue enjoying our trigonometric substitution. So we're looking at this problem, and you are dreading just one little thing about this problem that makes it the trig sub, and that's this square over here. If I erase this square, do you see that this problem is a basic Calc1 U sub? Yep. Yeah, right? And now I add a square over here, and then it becomes a trig sub. Look at that. Beautiful, right? So, we are going to have a lecture on this later when we cover more integration techniques. But there is a hierarchy in what you first try. Number one, you ask yourself, is the integral basic? Well, it's too busy, so clearly not. Then the second question is, can I use U sub? And if that's no, then you go with by parts or a trig sub or whatever other witchcraft we cover in classes right to come. So the job here, clearly we are learning trig sub, so it's going to be trig sub, but the job is also to realize what form of the question you have and what would be appropriate technique to solve that question. So when you see a square root, most of the time is going to be trig sub. But in some cases, it's going to be U sub. All right? So beware of the troll questions on your homework. Can you solve a question that it's a U sub question with a trig sub? The answer is yes. But it's equivalent of you driving here through Holland Tunnel. You all know you can, right? But you don't. All right, let's solve this problem. I have 1 minus x squared. So I have a negative. If I have a negative, the first thing under the root is hypotenuse. Great. So I'm going to put down the triangle, and hypotenuse is 1. This one is x. Therefore, over here I have 1 minus x squared. This is where my angle theta is. So standard setup. We know that we are going to circle and make the trig pairs towards the constant number 1. Now I have my red. For red, I am using opposite and hypotenuse, which is sine. I need you to sing that faster and synchronized. So we have sine theta is equal to x over 1. Well, it's just equal to x. Dx is equal to, the derivative of sine is cosine theta d theta. Blue is cosine theta is equal to the square root of 1 minus x squared over 1. So there's just square root is cosine. Now we plug everything in, and my x squared is sine squared x. The square root in the denominator is just cosine x. My dx is cosine, oh sorry, these are thetas. Cosine theta d theta, there we go, they're all thetas. Now we do see that the cosine dies right away, right? We have limits! Yeah, we are going to use, yes. we can plug, no, we plug them into a sign to change, right? So now, let's go purple. Limits. I have equation sine theta is equal to 1/2 for the lower limit, because x1 is 1/2. So what theta gives me 1/2 on the outside? Pi over 6, 30 degrees. Thank you. Pi over 6. Very good. It has to be in radians, otherwise calculations are not going to work out. It has to be radians. Sine theta equals √3 over 2. What do I get? Very good. So the limits are pi over 6 to pi over 3. What is the advantage of changing limits? We do not have to use inverse trig to go back to x. We can just plug in these numbers in whatever answer we get, and we're done.
Wait, was it √3 over 2 or just 3 over 2? How did you get √3 over 2?
√3 over 2 is given to us as a limit, upper limit of the... So we are transforming that, right? I need to integrate sine squared. You should be singing that song now. What is the method?
Angle?
Yes. Yes. So you can call that formula either power reducing or half angled. It's the same formula. Just move. So we are going to use the formula. And that is going to be, as you said, what? 1 minus cosine 2 theta, very good, over 2 d theta. The first integral is integral of 1/2. Well, let me write it down. So integral 1/2 d theta minus integral of 1/2 kick inside, outside cosine 2 theta d theta. Same pi over 6 limits.
You want to kick the 1/2 out first?
Well, it's going to be 1/2 theta. You can.
Okay.
So 1/2 theta minus 1/4 sine 2 theta, because when you integrate cosine 2 theta, there is a half that goes out. And now we have our pi over 6 to pi over 3 limits. We have 1/2 pi over 3 minus 1/4 sine of 2 pi over 3 minus 1/2 pi over 6. Minus and minus gives me plus 1/4 of sine of times 2 is pi over 3. There we go. So the first one is pi over 6 minus 1/4 sine of 2 pi over 3. So 2 pi over 3, wrong graph. So 2 pi over 3 is right here, pi over 3 √3 over 2, so √3 over 2, all students, it's positive value, you can see that. Minus pi over 12 plus 1/4 pi over 3 on sine is √3 over 2. Now these drop, and the answer is pi over 12. Nice. Hey, we did one of the...
So wait, sine of pi over 3 and sine of pi over 3 are the same?
Yes.
So how did you get those limits again?
I used the formula and I plugged in these original limits of 1/2 and √3/2. Those original limits are your x's. So I plug them in for x on this side, as you can see. Here's your 1/2. And then I used trigonometry to come up with a theta.
Use the inverse sign.
Yes, very good. Use the inverse sign.
Where do you use the inverse sign again?
Right here, when I focusing on this calculation, I use inverse sign on the side. It cancels this, and the inverse sign of 1/2 is pi/6. That's one of the ways to deal with this. Cool. Next problem. Oh, this looks cool.
Well, can you scroll up just a little bit? That's minus, wouldn't that be pi/6?
No, you have to make the denominator 12.
Oh, okay, I got you. Okay.
Yeah, I guess at first I was like, wait a minute.
I got you.
Oh wow! This looks out of order.
You have two left.
Well, where's my square root?
You have a square root, you have a 2 on there.
Exactly. Now, before we panic, what do we do? In which way do we? What kind of witchcraft are we going to employ here to get the square root somewhere? Is there a way to write x squared as a square root?
Square root of x to the fourth.
That's it, square root of x to the 4th, or you can write it x square root of x to the 4 on the outside. It doesn't matter. Hello, algebra, right? Hello, algebra. Because observe, there's no square root here. You know you're going to get square root when you draw the triangle, or if you memorize those 3 formulas from the book, they all have square roots in them. If your problem doesn't have a square root, your first order of business is to make one up, right? So, but you don't get to write it out of nowhere, all right? That's the way you dealt with things in algebra course. Over here, you are going to write the square root of 25 plus x squared to the 4th power dx, because the square root is a half, and then half times a 4 is a square that you used to have. Does this make any sense? If it doesn't, there is another way that we can deal with this, which I will point out when we get to it. All right. Triangle, theta, a cookie, and we have, well, they're available. They're right here. Oh, you noobs. I can't do nothing about that. We have a plus under the root, which means these are 2 legs. You can put this on any way you want. You can put x here and a 5 there, or you can switch it. Doesn't matter. And here it is. Pythagorean theorem. Now, you circle towards, actually wait, I want to red with x. I want to deal with x first. And then blue this way. Just going to see how many of you are writing in pen. No. That's going to be when we start plugging in. It's going to start floating around. I'm using red. Oh, by the way, the cookie has coconut. I hate coconut. I'm still eating it, so it's fine.
Coconut is the best.
See, that's why I said don't trust it.
Anyway,
Why didn't eat it? I mean, I'm telling you, you don't know.
I have a tangent over here. Tangent theta is equal to opposite over hypotenuse. Sorry, opposite over adjacent. Yes, thank you. Now, if you solve for x, x becomes 5 over tangent theta. So now you have that x is equal to 5 cotangent theta. This means that your pair, the way we wrote this triangle, is going to be cosecant cotangent pair. It's the one that you practice the least and the one that has minus signs all over the place. Is that the one you want to use? No. Can you escape it? Yes. It's very simple to escape this. Yes, you switch 5 and x. Very good. It doesn't matter where they are, because we know that under the square root that has a plus, there are 2 legs. It doesn't say which one goes where. It's just 2 legs. So, if you want to make this problem easier, and instead of dealing with secant cotangent cosecant pair, by swapping 5 and x over here, you are turning this problem into a tangent secant pair. Now, why is tangent secant better? It doesn't have minus signs as you differentiate and integrate. So you have less opportunities for mistakes. Oh, but I just forgot the minus signs. Well, your building collapsed, right? You don't get to make those excuses, right? The difference in the minus sign is, in acceleration, is the difference whether you push a brake pedal or the gas pedal. They're both acceleration. The only difference between them is the minus sign in technical terms on paper. Is there a big difference in a car? Yeah, it's called life and death. Right? So, you don't get to make those arguments. I'm sorry. So what I've just done is I swapped x and a 5 because I can. And now I am going to work with a secant tangent pair. So now my tangent theta is equal to x over 5. And x is 5 tangent theta. And dx is 5. The derivative of tangent is secant squared. Very good. Theta d theta. Very good. The same 2 people all the time. And now we have the blue one. Blue one is opposite and hypotenuse. No. Ha. I didn't switch so I was like, what the hell is wrong over here? There we go.
Oh, I didn't either.
Yeah, you have to circle with a number. I had the x circled with it. Adjacent hypotenuse is cosine. And then when you flip it, it will be secant. So we're good. So cosine theta is 5 over the square root. Square root is equal to 5 over cosine theta. And finally, square root is equal to 5 secant theta. Now the square root is 25 plus x squared. Yes.
So when you isolated x to solve for x, obviously, and it was 5 over tangent of theta, if you bring the tangent up, isn't it supposed to flip in the cotangent? It says x equals 5 tan of theta.
I just moved the 5 to the other side right here.
Oh, okay.
And then I swapped the sides. Okay. So I have my substitutions. Now, we can plug everything in. I have x squared. And I have x. Square it and plug in. So 25 tangent squared theta. That's your x squared. So here, this thing is your x squared, which is there. Divided by dx is going to be the 5 secant. So you have a 5 secant. Let's write it. 5 secant squared theta d theta is the dx replaced. Let's color that blue. That's your dx. And finally, you have your square root on the bottom, which is 5 secant. That has to be raised to the 4th power. 5 secant theta to the 4th power. Great. Whole bunch of stuff cancels now. What's happening with my 5s? Do we all see that I have 3 5s on the top? 5 times 5 for 25. 5 times 5 and then another 5 over here. So that's total of 3 5s on the top. And how many 5s do I have on the bottom? 4. So when I cancel the 3 on top and the 4 on the bottom, how many do I have? 1 on the bottom. So 1/5 in front of the integral sign. And then cookie. How many secants?
6. 2. 2 on the bottom.
2 on the bottom. So I have tangent square on top and secant square on the bottom and d theta and hello 8.3. Now we have to integrate this trig thingy. Now this probably would be much easier if the secant square was on top, but it's not. So
in those that last step, you just reduce that. Okay.
now when you look at this problem right here, it's obvious that your answer is 1/10 theta minus 1/20 sine 2 theta. It's obvious.
Oh, yeah.
But
Oh, yeah, shit. I knew that right away when I looked at it.
yeah, just like that, right? And then plus c at the end. Clearly.
What is that?
So how do we integrate this?
Yeah.
Excellent.
Yeah, and then you get the sine square.
You are going to break the tangent into sine over cosine. You're going to break the secant into 1 over cosine. And then cosines die, leaving just sine squared to integrate. Hey, it's a it's the power reducing formula we just had. So I memorized the answer and it's multiplied by 1/5. All right, let's go. Get busy.
And but you can't use you can use the half angle also, right?
Not the half angle, the power reducing, because this will reduce to a sine squared.
Okay.
This whole thing reduces to sine squared.
Okay.
So I'm just going to give you a few moments. You should get cookies while they're there. I think they're wrong.
No, this is easier to just break it down.
I'm wondering, like, what would it be for? Well, then why don't you take this?
Isn't that just science for the details? There's that
I
part.
like that.
It's just science for theta d theta, right? For the integral.
Yeah, but then you have to do
I didn't do after that. I don't care after that. I'm done.
the integration of science squared is cos 2
I forget exactly.
Wait, no.
I should probably memorize that. Actually, I think it's a good idea.
Yeah, you're right. Oh yeah, I need to memorize. Oh, that stupid thing. Is this what it, like? No, sine 2 goes to that.
I didn't do it.
What was the?
But yeah, you're doing the right thing.
I just gotta convert back.
Wait, you did 1 minus cosine theta over. Did you divide?
I pulled the 2 out. One out.
You took your 2 out. Okay.
So it ended up.
Just don't forget about it. Huh? Just don't forget about it.
Folding 1,000. Get out of there. It was over.
Your trick works. You came up with a trick any other week.
What? Not for you. Get how
I knew what I was doing.
I just walked. Pull it out of here. No, not for you.
Yes.
That's the only way that I remember that.
But that's what they call that's pairing to solve that's pairing that we use to solve this problem as a trig identities, but the pairs or derivatives are sine, cosine, tangent, cotangent. Oh.
Did you feel a little betrayed? Yeah. Well, I don't like that No, I don't think
I'm not something funny anymore.
Okay, so this is going to be 1 plus cosine 2 over minus cosine. It's 1 plus cosine 2 theta and 1 minus cosine 2 theta. Okay, so I take that and I times those two together and I flip it.
totally different thing.
So this is going to be. So when I
Absolutely not.
Oh, so you have 1.
I kicked the 1/2 outside with a 1/5, so it's 1 over 10. Okay, so here we have the solution in terms of trig.
That's not right.
Cosine 2.
Oh, I
Cosine to this.
Exactly, and then
You know why? You know why he did
Okay.
that? Because when he does it the other way, where it has 1 minus and 1 plus, and if he kicks that out and then he flips it and times it, it's going to be sine to the second, because it's sine plus sine.
Okay.
Okay, it made sense in my head.
What is the remaining cookie? Is it a coconut one?
I don't know.
It's broken.
Just eat it.
Oh, I don't want to.
Is that, I distributed, is that okay?
The answer is yes, but we are not done.
Oh, okay.
Because we have to go back to the x, right? We have theta.
Oh.
Now, hi everyone. Here is the solution up to the theta answer. And we have to go back to x. We don't have limits this time. So we don't get to compute in the theta domain. We have to go back into x domain, right, using the inverse transformations. Now, we do have a formula. We can read the sign off of the triangle, right? It will be x over the square root. But you don't have a sine of theta. You have sine of 2 theta. And this is where the identity that you must know for double angle kicks in. What's sine 2 theta using that formula? Sine 2 theta is? 2 sine theta cosine theta. Thank you. And then this 2 is going to kill this half. So we have 1 over 10, no coughing, over times theta minus sine theta cosine theta plus c. And now you can read your sine and your cosine from the triangle and use your inverse, whatever. We use inverse, we can use inverse tangent, x over 5, it's nice. So 1 over 10 tangent inverse of x over 5 minus sine is x over square root times the cosine, which is 5 over square root, plus c. And now we know the square root times square root, it cancels. So 1 over 10 inverse tangent of x over 5 minus 5x over 25 plus x squared plus c. There we go. So please, next time someone tells you, what do you know? Or if you ever tutor someone in algebra and they say on the equation with 5 lines, it's too long. Next problem. The fun doesn't end here.
I do. I need to start writing all those things down.
Yeah, no, but then somewhere in
All right, so how about you guys work on one of these? 38 looks really nice.
Okay, what you got? What you got?
It's a square root of 1 to square root of 2 dx divided by x squared square root of 4 minus x squared. Very civil. Is there a volunteer to do this on the board? Just for fun?
After I'm done.
No, before you do. Right now. Just walk out and start writing. show your math skills. All right. Now I gotta click it again. See Cookie Monster. Nice.
Oh, because if this is a negative here, then this automatically is your hypotenuse. If this is a plus here, then you have two legs. It's this guy right here. You gotta look at that sign.
So it's a minus, it's a plus.
Would that be cosine 2x? If you have sine theta is equal to x over 2. And then my dx is going to be...
Wait, you move the 2 first in front of the sign.
Oh.
So x equals 2 sine, and then you differentiate.
Oh, okay, I got you.
Is your dx quarter to sine theta to the power minus 3 over 4 cos theta?
dx? No.
Dx is
Because my x was 2 sine theta.
Yeah, my x was 2 sine theta too.
Yes.
No, mine was 2 sine theta to the power quarter, like under root 4.
I don't know why you have that.
Yeah, because don't you get 2 sine theta equal to x to the power?
No,
Oh, you times it.
No, I
You do
just
the
have
x
sine.
squared times the
Yeah, I
radical.
just have sine theta equals x over 2, so x equals 2 sine theta. I will try my best.
Wait, you took this as...
Because it's 4 minus.
Yeah, but don't you take the x squared side of it?
No, I didn't.
No, like what I'm saying, right? If you have this, like this, right? Can't you take the x squared side of it by making it x4 and then multiply it with these two, and then you do 4x squared and then minus x6?
Damn, I forgot the
I
deal.
didn't bother doing that because that would just make it way too long.
Yeah, like I have like no idea what it says right
I'm
now.
gonna handle x.
That's what happens. I get in the middle of something and I'm
So
like,
how do
oh.
you do it? I'm just gonna make I'm going to put this squared there. Like that.
Oh.
Yeah. Made it
You
a
took
line.
the X and
Look,
then
and I
you
literally just
took-
ended up with that.
Oh. So you don't need this entire thing to be an under root?
I don't think so, right?
No.
Like, the whole thing doesn't have to be under the root, right?
No,
Just a piece of it.
just a piece of it.
Yeah,
Yep.
you only need the D.
2 on a hypotenuse? Right here.
It's a 4.
That's a 4. Square root of 4 is 2. Because that's c squared. So if c squared is equal to 4, then c is 2.
Oh yeah.
The X squared is throwing me off. I'm just
Oh, we're gonna plug in. So you have your x.
Because you set up everything like normal, but then
This x squared, right?
yeah. So
So what is x squared? This is x. What's x squared? Perfect. Plug it in. 4 sine squared goes here.
if you have like another variable in that,
Oh, you can have as
set
many
it
as you
up.
want.
So you set it up with the square root stuff, and then you just
And you just replace it
That's what I
like blocks.
yeah.
So this x squared gets replaced with the square block, this square root with the block, the square root, dx with the block for dx, just swapping.
So I have a question. When do you know?
So one of the equation you will be able to isolate x.
No, it's just root 2.
There to get your dx, because you have to replace that piece with a d theta piece. So every problem, everything. Yes.
One of the biggest problems that I have is like I don't know when to do it themselves and when to do like my part.
That's everyone's going to have the same.
Takes time. Are they like or you know like
Just practice. And when we finish all of these, you will add more to the pile than those two, and then you will say, okay, this works. So it's over time.
But won't I just like take some?
Yes.
Then we'll have like
There is a reason why we say take this class in physics two, take this class with dynamics, take this class with mechanics.
No, but I mean like a lot of time when you're doing the question in the exam. Like if you try doing it one way and then you don't find it and then you do it another way, won't that take a long time for like
It will, but by that time,
I usually draw this going out, and I remember it.
isn't it gonna open up again, right, in the end?
yeah, are you eventually doing the entire movie last week?
I'm not even joking, like I was going to do the entire time, I didn't have time to do it, and then like I came back and I saw that there were like 3 of them.
I don't know.
As
I can't do it.
I know, so like
You just score.
yeah, so if it just working up for even like a night, I'll just like oh yeah. Okay, you just tell me when.
No, I was telling her I signed up for Cal 3 over there.
Oh, it's too much later.
Yeah, I don't know. I'm kind of scared. It feels pretty good. I'm just.
You know, I just think a lot about that.
I used to do
Thursday. We have 3 hours of this on Thursday.
Only 8 hours of eating, basically.
You know how to use like breakfast is like
Okay.
I take a class for public relations. In that class, they told us that is like a complete lie. That they just made that up to promote the sales of bacon for breakfast.
Interesting.
And there's like
You
a
signed up,
whole
right?
reasoning behind it, and when you go into it, it actually makes a lot of sense.
Easy as possible.
They asked a question.
You're not doing a good job with that, damn it.
Should have taken it somewhere else. All right, let's take a look at this mess. I already, as you can see, worked out our trig subs And now we plug everything in. The one thing I haven't done, and I have to do this, are limits. I'm using my x equation over here. So when x is equal to 1, which is the bottom limit, when x is equal to 1, oh, sorry, I'm using this one. So I have sine theta is equal to 1/2. And that happens, and I have a square root of 2 over 2, which is pi over 4. Very good. The dx is on the list as 2 cosine theta d theta. And now I have that x squared. Here is my x. What's the x squared? Well, it's 4 sine squared theta. And my square root is on the bottom as 2 cosine theta. All right, now. Why is that thing beeping over there?
Because somebody's backing up.
Why is it beeping when it's backing up? It kills more people going forward. It should be beeping going forward, not backwards. All right, let's go. Well, that's true.
We can reduce it
Anyway,
here.
yes, we're going to cancel things. We have a 2 cosine and a 2 cosine. That's done.
Yes.
And I'm going to kick a quarter in front of the integral. And I have 1 over sine squared. What is that?
Cosecant.
Squared. Now, what do we know about the cosecant squared? It's a basic integral, right? Aren't we all happy? Oh, come on. What makes you happy if that doesn't make you happy? I forgot to write theta equals pi over 4 over here. All right, so now we have 1/4, and cosecant square, we have a negative cotangent theta calculated between pi over 6 and pi over 4. So negative 1/4 of cotangent of pi over 4 minus the cotangent of pi over 6. No plus c in this case, right? So now what's the cotangent of pi over 4? 1. Negative 1/4, and that's 1. Minus, and the cotangent of pi over 6 is?
Not 1.
If you don't know, you will write cosine of pi over 6 divided by sine of pi over 6, and you better know this one.
Silence before.
Silence before. 1 over 4, 1 minus.
We just escaped that.
It's called a simplified answer. So the answer is about 1/4. Sorry. That's about 3. No, that's 3/4. About 3/16.
What kicked it out at the beginning?
From a long time ago. That's where it's coming from.
From the 8th century.
From the 8th century. Okay. I actually have 2 more examples that I want to work out in this class. And what do we have? We have 2 minutes left and then another 15 after that, so let's go.
Wait, what?
Yeah.
1 over 4 sine squared theta. So take that 1 over 4. This should be 4.
The longest part of all of this is looking up the stuff. Looking up the rule, making sure I have doing all that.
I made that up. Mike has no idea what he's done. I'm pretty sure. I made it up. It just sounds right. I'll put that one the 4. Yeah, with the 4. Yeah.
All right, so 2 more examples and we are done. Let's go with.
Yeah, 2 on the top would kill. No, I'm aware of that. Yep.
Now I will have to speed up this process a little bit. So.
I'm just writing it. Wolfram.
Wolfman.
That's right.
So here is the problem. Square root of 4x squared minus 1 divided by x squared dx.
Flip it.
And as we draw our triangle here, the theta, what is my hypotenuse? It's 2x this time.
Oh, you don't have to flip it?
I'll be on the top.
Oh, I didn't know that. Okay.
We've done too many of them in the denominator. Everyone just thinks that's the rule.
Oh, yeah. And now I have 1, and I have the square root. The other way. 1, and the square root of 4x squared minus 1, right? Mm-hmm. Because that would be the tangent, and that would be sec. Good. All right. So now I have my my red over here, which is the cosine theta of 1 over 2x, from where 2x is equal to 1 over cosine theta, which is secant theta. So x is equal to 1/2 secant theta, and immediately dx is equal to 1/2. And what's the derivative of secant? Very good.
No, secant, yeah, that one.
That one. There we go. Then we have our blue one, and the blue one is tangent. So tangent theta is going to be the square root of 4x squared minus 1 divided by 1. So the square root of 4x squared minus 1 is just tangent theta. So we don't have limits, so we don't have to convert anything. We just plug all of these in. So I have the integral, and my numerator up there is tangent theta, and the d theta is, what happened?
Oh, nothing. You'll.
And then 1/2, I know I was born sine, not sine, secant, say what you made me do. Secant theta, tangent theta, d theta. So I replaced so this part over here is the square root, and this part over here is the dx, and now all of that divided by x squared, which is 1/4 secant squared theta. Now we just need to clean this up. What's happening with my variables? 1/2 and 1/4 cancel to get the 1/2 in denominator, which works out to be a 2 outside. 1 secant dies with the secant on top. We have a tangent squared theta divided by the secant theta d theta. What now? The good old trick with going to sines and cosines is not going to work.
You can take that thing for a total. You can take
secant squared minus 1.
That's what
2 integral tangent is secant squared theta minus 1 divided by secant theta, d theta, and now this becomes simple. Secant and secant cancel, leaving you secant theta minus 1 over secant is cosine theta. These are two independent integrals. What's the integral for secant theta? That's not a basic one. Yes, very good. It's ln absolute of secant theta plus tangent theta, right? How do I know this? It came to me in a dream. Minus sine theta plus c. And all of this is multiplied by 2. Derivative of secant, integral of secant and integral of cosecant, those are not basic integrals. No, we use that special function and we use u sub. We did cover that in one of the lectures before. It's somewhere. We did it in the past. Because I remember you staying after the class, few of you, and asking me, well, how do you know to use this particular? And I said, well, someone who had a lot of time on their hands figured it out, and now we just know what to use.
So we can just memorize it.
Secant theta.
The answer is yes.
So secant theta is going to be ln absolute value of secant theta plus tan theta.
Yep. Now, we read all of these on our... No, we have to go back to X, right?
Oh, damn.
We're not done?
I boxed it in red.
Yes, our box is right now.
I guess it will be unboxing now. So secant, I have a secant theta here. So secant is 2x, great. Plus tangent. Tangent is a square root, great. Minus the sine. What's the sine? Square root over 2x. Plus c. Now let's say you doubt this answer. What can you do to check exactly? Right, so you differentiate this, and if you get the original problem, it's good to go. If you don't, there's an issue.
Yeah, you're not going to do it again.
No, you start from scratch because it's very difficult to find your own mistake. Right, it's your work. So you will actually save time by doing it from scratch than trying to figure out what minus you dropped or a half somewhere, because chances are you're not going to find it, right? It's easy for me to spot your mistakes because, you know, it's someone else looking, which is why engineers have layers. When you design something, someone else looks at it, and then someone else looks at it, then the boss looks at it, signs it off, then someone else, right? It's not like, oh, this battery is good to go, right? And then we get what? One more problem.
Do it.
All you need to do is to have good attitude towards this. It will work out. Let's do something completely different. Problem 66. Integral 1 to 4 dx divided by x squared minus 2x plus 10. There we go. Just to change the pace a little bit. This would be a basic integral if this x squared business was up there, right? With dx. That would be a calc 1. 4.9 question, right? The first question you answered. But it's in the denominator. Is it u sub? No. It's missing a derivative piece on top. We need integration by parts here would be to pick dx for dv and then 1 over this monstrosity for du. Try it. See what kind of horror you're going to get and immediately abandon it because it will be terrible, right? So we eliminated by this, right? We eliminated basic integration, u substitution, by parts, and obviously this is not a trig integral because it does not contain trigonometry in it. So by process of elimination, what is the only thing that is left? Wolfram. The only thing that is left is a trig sub, right? But then you're looking at this problem and you say trig sub, what? Where is my stop? Where is my square root and all of these kind of things? Well, what should we do here to come up with something that would have what we need? There is one mathematical. Yes.
Oh,
That's right.
Are you?
Exactly. Hello, algebra. This is yes. This is when you pull in a hat, right? Where there is a rabbit and an apple and all of this, and you pull completely square on. Right? Out of all the things that are in the hat, you pull the completely square. And when you
remember how to do that?
Yeah, I was wondering.
This is the problem. Do we have anyone who can do completing the square in Calculus 2?
The calculator.
The calculators can do.
You gotta put a 2 on the other side, and you divide, and you subtract, and you do something like that.
All right, so let's go to this mathematical witchcraft called completing the square.
That was the first problem in the last test.
Can you use that formula?
Get the square, get it right.
Is
No, that's for roots.
Oh, okay.
We are completing the square because this square is not complete at all. So we gotta complete it. Ready?
How about just times everything by 2 and make it a big 4?
How about we just plug the limits without integration and be done?
That sounds good.
That sounds good, right?
Times dx to both sides.
All right. So complete the square.
Just square the middle and
You
divide
gotta
by
add
2.
something.
Exactly. So x squared minus 2x plus 10.
Multiply the two.
We are going to group the first two. We are going to take the formula b divided by 2 squared,
Times.
which is in our case 2 divided by 2 squared, which is 1. And that's the magic number that we add and subtract within the parentheses. So now I have x squared minus 2x here in purple, plus 1 minus 1.
I knew you had that.
And then we have plus 10. Now, the first 3 are completing the square. Square root of the first, sine of the second, square root of the first squared. And then these two puppies over here are going to create the plus 9. This means that my problem now is dx divided by x minus 1 squared plus 9. And there's your triangle right there. You have two square things. You have a square parenthesis, so these are two legs. In my triangle, I have a leg that is x minus 1.
Why is it 2 legs?
I have, because it's a plus.
Oh,
It's a plus.
I was looking within the
And then over here I have a square root of x minus 1 squared plus 9 if you do Pythagorean theorem, right? So now we do our trig towards the number. And the good old friend completing the square is the one that helped us out to solve this problem. So now we have our red tangent theta is x minus 1 over 3. X minus 1 is 3 tangent theta. X is equal to 3 tangent theta plus 1. Dx is equal to 3 secant squared theta d theta. Done deal. Blue one. Cosine is equal to 3 secant theta. The square root is this long x minus 1 squared plus 9 thingy. Remember how I told you that you... So, square both sides over here to kill the square root, and then you can plug it in quickly. Okay, let's go. Integral divided by 9 secant 1/3 theta plus, oh no, plus c. We need limits. We need limits. Hold on. Hold your horses or whatever you have. To change our limits, let's go orange. When my x is 1, I get tangent theta is equal to 0, which means theta is 0. So my lower limit is 0. And when my upper limit is 4, I get tangent theta is equal to 4 minus 1 is 3, it's 1. And that happens that theta is pi over 4. So pi over 4, no coughing. So it is 1/3 pi over 4, which is, hey, pi over 12 again. So apparently all answers are pi over 12. I said don't do that. Right? Great. Trig's up. Huh? Thank you.
Post notes.
Understood.
And we don't have homework yet.
We will. Have a wonderful 2 days. When we come back, we are going to do some of the partial fraction decomposition. Some of you saw that in your pre-calc 1 class. Some of you did not. So we'll see how it goes.
We're going to have more homework. I thought you already gave us 8.4.